So this is 4.1, and what we're going to do today to start our Unit 4, woohoo, is we're going to redefine critical numbers, okay? So we're going to redefine, all we played with in Unit 2 was that the first derivative is equal to 0, but then in Unit 3 we talked about where a function is undefined, the derivative, not differentiable, okay? So I just need to tell you, surprise, a critical number is actually where the derivative equals 0 and where the derivative is undefined. And then we'll review increasing, decreasing, and max and mins and things like that. Oh, extrema. Do you know when the word extrema, do you know what it's talking about? Yeah, max or min. Okay, so write that, max or min. Okay, the first few questions we're only going to answer looking at this wonderful graph here. Do you remember the name of this? A cusp, yeah. So a cusp occurs when we have a 2/3 power. So graphically, what values of x does f have a relative max? Does this have a maximum, like a hill, anytime it's going from increasing to decreasing? Do you see anything? No, so no relative max. And is there a relative minimum here? Yeah, there is a minimum. Because a relative minimum is when something changes from decreasing to increasing. So there is a relative min at, and what's the coordinate point? Yeah, x equals -1 is good, but since we know the y value, we'll write it. What can be said about the derivative at the value indicated above? So, do you remember? Like, what do we say the derivative, what's happening at a cusp? The derivative is undefined, right? It's not differentiable, right? So, what can be said about f prime? F prime is undefined because there is a cusp. Okay. Do we still have intervals of increasing and decreasing? Yeah. So let's write those down. So f is increasing. So where's the slope positive? -1 to infinity. Yep. And decreasing. From -infinity to the -1. But on this graph, is there anywhere where the derivative is equal to 0, which means a horizontal tangent line? No. So no, there's no max and there's no min, but like the max and mins that we know and love, okay? The beautiful hill or the valley. There's a minimum, but it's a cusp. You agree? And the cusp means the derivative is undefined. So there's no horizontal tangent line, only the cusp. Okay? Analytically, so that means we're going to actually find the derivative. You ready? Algebraically find f prime, then perform the sign analysis of f prime using any value that makes the derivative equal to 0 or undefined. Ready? Get set. F prime. What rule are we going to use here to take this derivative? Chain rule, yep. So we have a 2/3 power, and we're going to bring it down in front. So 2/3 is a coefficient, and the inside stays the same. And what's 2/3 minus 1? So if you get confused, we're going to go -3/3. So it'd be -1/3. Multiply by the derivative of the inside, which is 1. And what's the derivative of the constant 2? 0. Okay. Let's simplify this. what does the 1/3 power mean? A cube root, yeah? So not a square root, but it's going to be a root with a 3 in here. A cube root of x plus 1. Okay, we're going to analytically, yeah. What negative? So that is a negative power, a negative exponent. This is all to the power. So all that means is move the parentheses to the denominator. Good question. Okay, ladies and gentlemen, we're going to algebraically find where is this derivative equal to 0. And then we're going to figure out where is the derivative undefined. I'm seeing a lot of students not write titles when I write a title on my work, okay? If you skip the title or your labels, then your work is a complete mess and you don't understand it and I don't understand it, okay? So some of the free responses yesterday were really difficult to grade because you didn't use the same labels that we did in the notes, where we put continuous, differentiable, system. Also the same thing with the tangent line. Y value, slope, tangent line, okay? You guys, for the first time in math, you're being asked to find like 3 things in one question, so you need to organize your work. Got that? Here we go. So you have to declare to the reader, just like if you're writing an essay, declare to the reader, this is where I'm finding the derivatives equal to 0. Label your work. Ready, get set? This is our derivative, right? What are we going to do? Set it equal to 0. I don't know what I just said. All right, what should we do with a fraction? When a fraction is set equal to 0, multiply by the, yeah, we multiply both sides by this denominator. It would cancel, right? It would divide out. And what happens when we multiply this denominator by 0? 0. Hey, does 2 ever equal 0? No, so no solution. What did we say on part D right here? Did we say the derivative ever equals 0? What did we put? We put no, it never equals 0. What did we just find algebraically? Never equals 0. Okay. Okay. Where is this derivative undefined? How is something undefined? 2 ways something's undefined. Ready? When the denominator equals 0, should we write this down? This is notes, right? Let's go up here. Do you see this undefined? Okay. 2 ways a function's undefined that we'll talk about today. When the denominator equals 0, or if you have a square root, not a cube root, a square root of a negative number. Square root of a negative. You agree? Yeah? Okay. What's our function that we're looking at? A denominator or a square root? It's not a square root because it's a cube. So, but do we have a denominator? Okay, so to see if this is undefined, we're going to set denominator equal to 0. All right, let's solve from here. Step 1. Divide by 3, and 0 divided by 3 is 0. Step 2. Cube. Cube both sides, yep. Okay, and what's 0 cubed? 0. Solve for x. What does x equal? What did we just find? We just found where, I don't know. I'm lost. I'm confused. I'm thinking about something else. I'm thinking about what I'm having for lunch today. But good thing I put this title here. Okay, so this title tells me I just found where the derivative is undefined. So if the question says, hey, where is this undefined? You're going to say where? -1. What the heck? What did we say the graph was happening at -1? A cusp. What's happening at a cusp? The derivative is undefined. Cool? So we just proved what we talked about graphically. We just proved it analytically using equations. And does the sign analysis establish what is depicted graphically above? I would like to just say yes and move on, but we're going to answer this. Okay, ready? Find room. Sign chart. Remember first derivative sign chart? -1 is our critical number. -1 is our critical number, and we're going to plug these into the derivative to see if the derivative is positive or negative. And we already know it's going to be a minimum, right? Okay, this is all review, yes? Are you with me? Wake up, wake up. Here we go. What's a number less than -1? -2. Do it in your head. -2 plus 1. -1. The cube root of a negative will come out negative. So do we have a positive divided by a negative? So that means the derivative is negative, which means the function is decreasing. But we already know that, right? Because we have a picture of it. Yes? We know it's decreasing. Decrease in, if you want to be cool. You could leave the G off. What's a number greater than -1? 0, 0. And here, is this going to be, this video is all messed up. Is it going to be positive or negative? Positive? With me? Is it hard yet? No, it's not. Increasing. Does the sign analysis establish what's depicted graphically above? Yes. Yes, it does. All right, let's do another example. Ready? Get set. Algebraically find the derivative. We can do that. We can do that. Ready for your quotient rule? Low D high minus high D low. We like the numerator because the derivative of 3 is 0. Low D high minus high. What's the derivative of the denominator? 2x. Can this be simplified? Yeah. Oops. What do we have to do with the denominator? Square it, pay attention to details. Here we go. We're okay? Okay on our denominator? Now, to find critical numbers, we need to find where the derivative is. We need to do two things. What are the two things we have to do? Where it's what? Equals 0 or undefined. Okay? This is a big idea of today's lesson. Set the derivative equal to 0 and find where it's undefined. Ready? Get set. Here's my title of the work I'm doing. We're going to set the derivative equal to 0. And solve for x. Multiply the entire denominator on both sides, and what happens to it? Cancels, it goes away. If negative 6x equals 0, what will x equal? 0. How do we find where it's undefined? Set denominator equal to 0. And then solve for x there.